Alright, so after the code was written, I'm just going to show this in the Brave browser, and here you can see, here is what it wrote: a system modder, status online, showing the neural load, the VRAM saturation, my network activity, and system override. So if I click system override, it goes to a red shake. Wow, that's quite interesting. Alright, so this is what it was created in just a matter of seconds. Now, if I can show you that, this is what it prompted out after. So we were doing 181, read this right, it's 181 tokens per second. Or was it 5 tokens per second? Let's just put this into context here. Copy this to Gemini and ask what it just did. So I just asked it, so this is the output for the first test, what did it show? And I'll paste it in there and we're going to read out. So let's just bring this out and show you what actually Gemini's response was. These logs show a powerhouse performance for the Cyberpunk dashboard test. Your 5 GPU rig just flexed its muscle, and the efficiency of the MTP multi-token prediction was even higher than before. Here's the breakdown of what happened under the hood. Speed stats, higher efficiency than last time. Reading, prompt evaluation, 181.37 tokens per second. It swallowed your code instructions in a fraction of a second. Writing evaluation time, 25.67 tokens per second. This is a significant jump from 20 tokens per second in the last test. Why? Coding is highly structured. Models and their draft counterparts are often better at predicting brackets, semicolons, and common keywords than they are at creative prose. The draft MPP, draft acceptance rate, 98.01%. This is nearly perfect. Out of 2,472 draft tokens generated, your main model accepted 2,423 of them. This basically means almost every single word of code your draft model guessed correctly, allowing your GPU to skip forward. This is why it felt so fast. Smart recovery management, the cache shift. The log shows a common part does not match fully. Warning followed by cache. Analyze the long-term prompt. Create a long single file. What this means, Llama server noticed that your new Cyberpunk prompt was totally different from the superconductor prompt. The action, it intelligently erased the old context checkpoints, the 150 MIB blocks, to make room for the new coding project. Result, you now have a fresh 4054 token cache for this coding project. If you ask it to change the colors to neon green, it will respond instantly because it has the current code stored in its KV cache. About 757 MIB total state. Code complexity. Total output 4055 tokens. That is a massive amount of code for a single file. It likely includes complex CSS, multiple JavaScript functions, and the full HTML structure. Summary for your video. If you're narrating this part of your YouTube video, you can say, even with a complex 4,000 token coding task, the rig maintained over 25 tokens per second with a 98% draft acceptance rate. The multi-token prediction is essentially finishing the model sentence for it, making local inference feel faster than many cloud-based APIs. Did you save the output to an HTML file yet? I'd love to know if the Cyberpunk visuals turned out as neon as we hoped. So that was Gemini's response to this, and yes, it did pump out a neon looking activity, system override, shaking, so definitely I give it a hands up for that. So the second test that we're supposed to run is the following. I can just find it. It is a Newtonian gravity sandbox. This is a pure logic test. It checks if the model actually understands physics and coordinates geometry rather than just copying a template. So here's the prompt: write a complete HTML.js application that simulates a 2D gravity sandbox. Alright, well, I'll try and get the prompt going first. Let's look at the prompt here. New conversation. I'm going to paste that in. Alright, that's the prompt. It doesn't seem so big. Alright, but maybe it'd be better for me to show it to you like this. So it's write a complete HTML.js application that simulates a 2D gravity sandbox. Physics: implement a particle system where particles are attracted to the user's mouse cursor based on an inverse square law. Graphics: use an HTML5 canvas. Each particle will leave a short fading trail behind it to show its velocity and path. Controls: add a sidebar with sliders to adjust gravity strength, particle friction, and particle count up to 1000. Performance: optimize the draw loop so it stays at 60 frames per second even with 500 plus particles. Now, let's see if that can actually run. This is the prompt over here. Let me bring up my here we go. We've got the prompt running, and we've got the SMI running. Let's click this on first, and now let's do that. Straight away 99% on the first GPU. So as you can see, it's thinking over here. And then it's actually doing the output over here. So it's doing heavy work, as you can see, on the GPUs. And now it's starting to give the thought process out as an HTML format. So that's pretty quick. I don't think it's going to take that long to write the whole thing out. But remember, it's structured data, so it will do it pretty fast. And as you can see, it's not using the GPUs to its fullest capacity. I mean, the first GPU where all the monitors are running at 54%. The others are 12, 32, 12 and 11. Alright, and this over here, it's starting to do the CSS for me. I mean, I personally wouldn't be able to run this myself or be able to do the code itself. I mean, this is a model that will do the code for me if I need to output something. So here we go. There's some of the code it's writing, and here is the rate at which it's using the GPUs. I can only think it's using the one over the other faster because of the monitors on the first GPU, which is running at 55% right now. And I'm also running screen recording software. So you can imagine that with utilizing all the 5 GPUs plus the screen recording software, it's taking up a lot of beating. There it's just explaining what's happening. And it's done. GPUs are back to 0 and the other one to 31% because of course I'm still recording. So let's just stop this and I'll get back to you. Alright, so let's just make this bigger so we can see. It's done the full stream, and it's also done the physics behind it. So how can I best lay this out? If it didn't, well, it did finish all the HTML, so let's try and just create this in a different file for a sec. let's just copy this and paste it here. And the last, oh, it only copied the HTML, so that's fine. Now let's save this in a, let's call it test2.html. You save it in that folder. And remember, this is a Cyberpunk one. So let's now open the test2 in the browser. Alright, so there we go. Wow, that's absolutely fantastic. That's a gravity sandbox. Unbelievable. It's showing the frames per second, the particles, the average speed. And if I click on the mouse here, it goes buck wild. You can obviously change the gravity strength, you can change the particle count, you can change the trail length, and you can change the mouse mass. So that's just unbelievable. I love it. Reset the particles, and there we go. Move your mouse to attract particles. Brilliant. Whoa, that is awesome. I'm inspired to do something better with this. So there you have it, folks. That is the Gravity Sandbox created by a IK_llama.cpp setup. Now let's find out and ask Gemini how the second results came into being. What do we actually think of it? So let's just copy this last section of the prompt here. I'm getting 176.3 tokens per second. But let's see what we can get from this little. Alright, so let's just say from the second prompt, this is what we got. Please comment. Please provide your opinion on it. So I'm going to paste that in and see what Gemini thinks of this one. Now, according to Gemini, you can read it here yourself. This second log is even more impressive than the first. You've moved from a 4,000 token coding task to a massive 6,180 token generation for the Gravity Sandbox, and the stability of the 5 GPUs is essentially production grade at this point. Here is my technical opinion on these results. The code specialist efficiency. Your draft accept rate stayed at the staggering 97.2%. Translation: for every 100 tokens the small draft model guessed, the big model only had to correct it 3 times. Why this matters? In the world of LLMs, code is much more predictable than human conversation. Your MTP, multi-token prediction setup, is effectively teleporting through the boilerplate code, which is why you're maintaining 24.45 tokens per second on a 27B model. Most people running this on a single 3090 would be lucky to hit 10 to 12 tokens per second. Throughput and endurance. Total generation. You generated 6,023 tokens in roughly 4 minutes. The stress factor. Generating 6K tokens of functional JavaScript is a heavy lift for model's logic. If there were going to be a hallucination or a crash due to VRAM overflow, it usually happens around this length. The fact that it finished successfully means your memory distribution across those 3 3070 and 23080s is perfectly balanced. Small cache recycling. The logs show the server is doing exactly what it is supposed to do when you switch tasks. It noticed the Cyberpunk prompt didn't match the Gravity Box prompt. It erased invalidated checkpoints, cleaning out about 300 MB of old KB cache. It immediately created a new 1079 token cache checkpoint. The benefit: if you now ask the model to make the particles blue, it will start generating the answer in less than a second, because it has that 6,000 token sandbox codebase saved in RAM. Technical observation. the sliding window attention. The log mentions forcing full prompt reprocessing due to a lack of cache data, likely due to SMI. Opinion: this is a quirk of the Qwen Gemma architectures in llama.cpp. Since they use sliding window attention, cache isn't always linear. The rig's response: your rig is so fast, 176.30 prompts tokens per second, but even when it's forced to reprocess the prompt, it only takes 890 milliseconds. On a weaker CPU GPU setup, that reprocessing might take 10 to 20 seconds, causing a lag before the AI starts typing. You aren't seeing that lag because your hardware is brute forcing through it. Final verdict. Alright, so there we have it, folks. That is the video for today. I hope you get some idea as to what we're running. Stay cool and calm.